Hi everyone, today we're going to continue with balancing, but we're going to tackle word equations because you not only need to know balancing, but in order to balance you've got to have the correct formulas as well. So if you don't have correct formulas, then in some cases you're never ever going to balance. It's just not going to work. So we're going to start right into it and give an example of copper plus water yields copper 2 oxide plus hydrogen. Now, in later notes, we'll talk about how to get each of these reactions, but for now we're just worried about the words and making sure that we write them correctly. Okay, so copper, you just write Cu, it's not diatomic, plus water, H2O, copper 2 oxide, so now you've got to know your nomenclature rules. So copper 2 means plus 2, oxide means minus 2, put them together to get CuO, plus hydrogen. Hydrogen is diatomic, so you need that too. So now we're going to count up our atoms. On the left side I have 1 copper, and the right side I have 1 copper. On the left I have 2 hydrogen, on the right I have 2 hydrogen, and on the left I have 1 oxygen, and the right I have 1 oxygen. So this one's balanced, so we don't need to do anything. It's always nice when that works out. Alright, next example we're going to have is, I'm going to have to write this one a little smaller to fit all of it. Aluminum nitrate plus sodium hydroxide. When these two come together, they make aluminum hydroxide plus sodium nitrate. And now we need to work on our polyatomic ions. So aluminum is a plus 3, nitrate is a minus 1. Alright, put those together, I get AlNO3 3 plus sodium hydroxide. Sodium is in the first column. It's just 1 valence, it's a plus 1. Hydroxide is OH with a minus 1 charge, so put those together, I get NaOH. We use that one quite often. Aluminum, again, it's a plus 3. Hydroxide is an OH with a minus 1 charge. Put them together, I get AlOH3. And sodium nitrate. Sodium, again, first column, plus 1. Nitrate, NO3, minus 1. Put them together, NaNO3. Alright, there's a lot there, so we need to try and make sure we're counting up all of our numbers here. Alright, I've got 1 Al on the left, 1 Al on the right. I've got 1 Na on the left, 1 Na on the right. Where my numbers change are in my polyatomics. Now you can look at individuals here. You can say there are 3 nitrogens on the left. You can also usually just say there are 3 nitrates on the left. So I'm going to use the whole polyatomic. There are 3 nitrates on the left, and on the right I've got 1 nitrate. So that means I need more nitrate on the right. But remember, you have to add the entire molecule. You can't just add a half a molecule. Well, that just changed my sodiums. I now have 3 sodiums on the right, and I have 1 sodium on the left. So I need more sodiums on the left to give me 3 of those. And actually, that should fix it, because even though I have 3 hydroxides on the right, well, since I just added those, I now have 3 on the left. So if I'm rewriting this, I have AlNO3, 3, there's only 1 of those, plus NaOH, I have 3 of those, 1, 2, 3, yields AlOH3, only have 1 of those, and NaNO3, and I have 3 of those. 1, 2, 3. And there is my final answer, balanced in full. All right, I'm going to do one more example here. This one is going to be potassium nitrate. This is going to be a decomposition reaction, which we'll talk about in a few classes. Potassium nitrate decomposes to potassium nitrite plus oxygen. All right, so we're going to use our nomenclature rules here. Potassium, first column, is a +1. Nitrate, polyatomic, NO3 -1. Put them together, I get KNO3. And that yields potassium nitrite. Again, potassium is a +1. Nitrite means one less oxygen, so NO2. Put those together, I get KNO2. And then I have my oxygen, which is diatomic. I got to have that little subscript too. All right. Now, at first, it looks pretty close, but then you have to look at your oxygens. This is where you do have to separate out the polyatomics. So, I have one potassium on the left, one potassium on the right. I have one nitrogen on the left, one nitrogen on the right. I have 3 oxygens on the left, but I have 1, 2, 3, 4 oxygens on the right. Well, since the right has more, that means I have to add to the left, so KNO3. And what that did was that changed everything. It changed my potassiums, it changed my nitrogens, and it changed my oxygens. So I need to be careful about which oxygen I add this time. Since I changed my potassiums and my nitrogen, I think I want to add that. And if you look at that, now I've got 1, 2 Ks, 1, 2 Ks. All right, I've got 1, 2 nitrogen, 1, 2 nitrogen. And then for all of my oxygens, 1, 2, 3, 4, 5, 6 on the left, and 1, 2, 3, 4, 5, 6 on the right. So everything is now balanced. And we can write our formula. So I have 2 KNO3 yields 2 KNO2 plus O2. And that's it. All right. And that's what balancing word equations is all about. It's just making sure that you know your nomenclature and your ionic rules and your valence electrons, et cetera, et cetera. So now we're really starting to put all of our chemistry knowledge together and starting to use it on a daily basis. So make sure that you're understanding your formulas, and as long as your formulas are right, the balancing should go pretty quickly. Okay. Next class, we're going to look at synthesis reactions and how to finish out and get the products of those. All right. Until then, work together, help each other, and make the world a better place. See ya.